Hello, my name is Jack Stengel. I am an applications engineer for Minco Products. We're a manufacturer located in Minneapolis, Minnesota, and we produce everything from heater circuits to flex circuits, as well as sensing and instrumentation for control electronics. Today I'm very excited to be able to announce a new technology that we've just recently launched called SmartHeat. It's a new product line that combines some of our traditional elements, heating, sensing, and control, into a single thin film package. So the goal today is to demonstrate the new technology, show you some of the features and benefits that it has to offer. And to do that, we have a number of setups on the table here. We're going to walk through these one by one and take a look at some of the key benefits from stability to safety and simplicity. So to begin, we'll take a look at stability, and for that, we've set up a side-by-side demonstration of our traditional etched foil heater compared to the new SmartHeat technology, and we'll show how they can respond to unique and diverse loads. For the second part of the demo, we're going to take a look at safety. Field failures are a concern for just about every manufacturer. We want to limit those as best we can, and SmartHeat has a number of built-in safety features that will help us reduce those failure rates. And then lastly, we'll take a look at simplicity. Anytime that we can reduce the number of materials in a BOM, we're going to cut down on cost, cut down on weight for some of our more sensitive applications. And this is a great technology for combining together some of those external electronics into a single package. We can actually build in control, sense, and heat within a single layer of our circuit. So I think at this point, let's get started. We'll take a look at stability first and dive into the testing. For this part of the demonstration, we're going to talk about stability. Minco produces a number of heaters that go into some very dynamic environments. You might have extreme cold in one scenario, and then the next day there's a very warm environment surrounding the heater. We need our technology to be able to adapt to that environment and still warm the object of interest to the correct temperature. In addition, we could have heat sinks with very dynamic loading. That's actually what we have set up here as a demonstration piece. We have a combination of acrylic and aluminum that are being heated by the same heater. Traditionally, what we would do is profile our etched foil heater. We would create a very different resistance density in each location. That requires some simulation work, a lot of design time on the front end. SmartHeat can really help us to reduce that upfront effort and just produce a heater that works day in and day out for a variety of situations. So to jump into the demo, I want to take a quick second to talk about what each one of these M's represents. The M on the right, this is a traditional etched foil heater. If we focus in close here on the components that are built into it, you can see there's a power connector as well as a number of controlling electronics and a sensor that's built into the heat zone. On the left here, we have a SmartHeat device which only has power. So it's a simple connector that's built in to get a voltage applied to the SmartHeat device, but there's no additional electronics. And that's really one of the big benefits that SmartHeat can provide. If we look on the back side of each one, they both have the same acrylic window built in. So this demonstrates two very different heat sinks, aluminum with a high thermal conductivity and acrylic with a very low one. When we power this up, the sensor for the traditional element is located right here. So it has no awareness of what's happening in the acrylic region. The SmartHeat device, on the other hand, will actually sense at every location across its surface. So when it controls, it does so on a point-by-point basis. It'll be able to have some awareness that the acrylic is there and that it needs to put out less power in that region to reach the same set point. So let's begin by turning on the power, and we've got an infrared camera set up that's going to capture the thermal image of both heaters as they turn on and go through their warm-up cycle, and then we'll take a look at how each one performs. So let's go ahead and turn on the supply, and we'll be able to watch on the thermal image and see how each heater performs side by side. So to begin, we'll flip this on. So right now we're set to about 14 volts. We can design SmartHeat to any voltage really, up to about 240 volts. In this case, we just have it set for 14 for demonstration purposes. So right now on the thermal image, what you'll see, I'm kind of referencing off to the side here as I look at the camera. The initial power-up phase, you can see that the SmartHeat device on the left is actually producing tremendous power up front. so it kind of has a head start in the race toward the set point. The one on the right here, the traditional etched foil heater, will reach its set point in about the same amount of time, but it's going to be more of a slow and steady pace in getting there. One of the key advantages to SmartHeat is the amount of power that it can deliver at low temperature, and then it tapers off very quickly once it approaches its set point. So right now, we can start to see some hotspots forming in the thermal image. Right now, in the heater on the left, the SmartHeat device, the acrylic window does show a little bit of non-uniformity, but compared to the heater on the right, the traditional one, it's actually quite stable. And right now, we're looking at about 100 degrees C within this acrylic region and about 60 degrees C in the SmartHeat device. So this is intended to show or demonstrate a hotspot that would form in the case of delamination. Maybe a heater has kind of peeled up from the edge. If there was a poor bond during the initial installation process, the SmartHeat device is able to compensate and scale back its power output in those regions of interest. So the intent here was to show the difference in thermal loading between a SmartHeat device and a traditional etched foil device. Both heaters are able to maintain the same temperature set point, but we see that there's a significantly higher degree of stability with the SmartHeat technology, where the sensor itself is built into the raw material and can actually sense at each point along the surface. By comparison, if we take a look at the traditional one, the sensor is located right here, and we can actually see now that it's at steady state, the duty cycle, which is shown by the flashing LED. Right now, this is a very high degree of pulsing that's occurring. So you can see it's flashing very quickly in order to maintain set point, turning the heater on and off. By comparison, the SmartHeat device is always on. It effectively has 100% duty cycle. But what's happening internally is rather than switching on and off, it's using a mechanism, thermal expansion essentially, where this black silicone layer here has been doped with carbon black. The carbon itself will expand along with the silicone when the heater turns on, and that will create the self-limiting behavior as those conductive particles are stretched apart. It'll reach its set point and will only output as much power as is needed in order to maintain temperature. So at this point, we'll kind of close off the stability demonstration and move on to talk about safety. So let's go ahead and get that piece of the demonstration set up. Next, we'll take a look at safety. What we have here set up are two heaters, one of them a traditional etched element heater, the other one a new SmartHeat device. We're going to compare them side by side and actually introduce some mechanical damage to each one. So we have a hole punch set up with a hammer. We're going to put a hole into each one and then take a look at the thermal image. We're going to place a camera overhead and actually see how each heater performs thermally. And what we expect to see is that the traditional heater might shut off while the new SmartHeat device is capable of continuing operation even after mechanical damage. So for this setup, we're already at steady state, so the power supply is set to 14 volts. Both heaters are at equilibrium, so they're at the same set point. The difference here is that SmartHeat is uncontrolled, so it's internal, it's built in, but it still reaches the same set point as the traditional heater, which has a Minco CT325 controller powering it behind the scenes. So let's go ahead and get set up. We're going to move the thermal camera over and get an overhead shot, and then we'll get back to the testing. So right now you can see each of the two heaters has a hole punched through it. In the case of the traditional etched element heater, we actually saw the circuit broken, the entire heater shut down, and we no longer have heat produced. In the case of the Smart device, we actually have operational heated area above and below where the hole was punched. So that represents areas that would still remain functional even in the case of physical damage in this case a hole that was punched through the heater. So at this point we'll wrap up this part of the demo and move on to talk about simplicity, look a little bit into the cost benefits of SmartHeat and also some of the weight reduction that can occur with this sort of technology. For the last piece of the demonstration, I want to talk a little bit about simplicity. There are quite a few benefits that come along with purchasing a SmartHeat product, primarily regarding risk, time to market, and also cost and weight. So we'll spend a little bit of time here talking about those. So when it comes to risk, any additional components that get added to an assembly are added potential points of failure. With SmartHeat, you have all three devices, heat, sense, and control, all within a single thin film package. So there's no additional external components that may cause failure for the assembly. When it comes to time to market, on the front end of the design, there's quite a bit of work that goes into thermal simulation on the mechanical side. For an electronics engineer, there might be a lot of work in pairing the controller, the sensor, and the heater all together, getting them to communicate well with one another. With SmartHeat, we're combining all into one package, so there's no additional need for an engineer to step in and pair or combine the electronics together. And then lastly, with regard to cost and to weight, every additional component adds a line on the bill of materials, which adds cost to the system. We often find that by adding just a little bit of cost into the heater, we can take a tremendous amount of cost away from another point in the system. And along with that comes with weight. A SmartHeat device is not significantly heavier than a traditional etched foil element. And to illustrate that, we're going to do a little side-by-side and show how the heaters compare, and then add in some of the external electronics that are also required with the traditional technology. So first off, a SmartHeat device. This is a standard construction for a SmartHeat heater. Comes in just under 5 grams total weight, and this is the entire package. So there's no other components that need to be paired with it other than to give it a power source. When we look at more of a traditional design, we can see that the weight comes in a little bit lower. Right now we're at about 3.2 grams, but then we have to take into account the fact that we'll need a controller. That's going to add quite a bit of weight. And then we'll also need a sensor to provide some feedback for the system. And by the time this assembly comes together, we're talking about nearly 38 grams. So this is really the simplicity that SmartHeat offers. We can take away those extra components and stick with a single device that does all in one. So this just about wraps up our demonstration. We've talked about some of the key features that SmartHeat can bring to applications in thermal solutions. We started off talking a little bit about stability, looking at an actual warm-up cycle for 2 heaters, traditional and SmartHeat, and seeing how the SmartHeat device can respond to dynamic loads and unique heat sinks. We spent a little bit of time talking about safety. SmartHeat is a very damage-tolerant device. We're very excited to see where it can find a place in our key markets. Has a tremendous ability to recover from mechanical damage and to still produce a good heat output regardless of its environment. And then lastly, we talked a little bit about simplicity, trying to keep costs down, keep weight down. We have plenty of applications that could certainly benefit from this. We hope that you guys are as excited as we are about the benefits that SmartHeat can bring. So thank you very much for watching. Right now we have heaters available on mincocomponents.com, so you can purchase off-the-shelf heaters for proof of concept testing, and then as soon as you're ready for a custom solution, we'll be happy to work through that process and provide you with the best heater for your application. Thanks again.